For this example, we are going to find the homogeneous linear differential equation with constant coefficients whose general solution is given. In part A, the general solution is C1 e to the x plus C2 e to the 3x. Therefore, the y1 is e to the x, y2 is e to the 3x. Recall the solution is y equals e to the power mx. For y1, we get m1 equals 1. y2, we have m2 equals 3. And then put it back into the auxiliary equation, which means we have the form of the equation as a factor like m minus 1 multiplied by m minus 3 equals 0. And then expand or multiply these two factors to get the equation or the auxiliary equation that tell us the auxiliary equation is of the form m squared minus 4m plus 3 equals 0. And then we write it back into the differential equation, which is the homogeneous linear equation with the constant coefficient. The coefficient of the power 2 is the coefficient of the second power. Coefficient of the first power is the coefficient of the first order. And 3 is the value of the zero order, which is the y equals 0. Then we get the differential equation in the form of y double prime minus 4y prime plus 3y equals 0. In part B, we have y equals c1 e to the negative x times cosine of 2x plus c2 e to the negative x times sine of 2x. We see c1 and c2 and the common exponential term. Factor exponential term as e to the negative x multiplied by c1 times cosine of 2x plus c2 times sine of 2x. With this form, it is in the case of you have the conjugate complex solution as the pattern y equals e to the alpha x multiplied by c1 cosine times beta x plus c2 sine of beta x. For part B, the alpha is -1, the beta is 2. That gives us the conjugate complex in the form of the alpha plus minus beta I or -1 plus minus 2i. So with m equals -1 plus minus 2i, we're gonna put them back together as the auxiliary equation by forming the equation for the m. M equals -1 plus minus 2i, or m plus 1 equals plus minus 2i, raised to the second power both sides. So we have m squared plus 2m plus 1 equals 4 times -1, which is I squared. And then rearrange the term to get m squared plus 2m plus 5 equals 0, which is the auxiliary equation. And next, form the differential equation. The coefficient 1 of the second power or the second derivative, coefficient 2 of the first order or the first derivative, and then 5 times the zero order or just y equals 0. The last example, we have y equals c1 plus c2x plus c3 e to the 3x plus c4 x times e to the 3x. We have c1, c2, c3, c4. That means we have 4 solutions. See the first one and the second one, or c1 and c2, we have no exponential form. We can rewrite it as c1 times e to the 0x plus C2 x times e to the 0x, and then plus C3 e to the 3x plus C4 x e to the 3x. Now we can see repeated solution, the two sets of the repeated solution. M1 equals 0, M2 equals 0 as well. M3 equals 3, which is the same as M4, which is 3, because you have the same M value, and the repeated one will be multiplied by the X factor. Now we have 4 M's, 0, 0, 3, and 3, and form the auxiliary equation M minus 0 times M minus 0 times M minus 3 times M minus 3 equals 0 to get M squared multiplied by M squared minus 6M plus 9 equals 0, or M to the fourth minus 6M to the third power plus 9 times M to the second equals 0, which is the auxiliary equation. And next, we rewrite the differential equation. The coefficient of the fourth power is the same of the coefficient of the fourth order. Minus 6, the third power, gives the same coefficient to the third order. And then 9 as a coefficient of the second order equals 0. And this is the differential equation to the given general solution.